Electrostatics, dipole and dipole moment. Two equal and opposite charges separated by certain distance form a dipole. This distance is taken to be 2a. Dipole moment is written as P, which is given by 2aq. It is a vector quantity. Its direction is from minus q to plus q. The unit of P is Coulomb meter. Now, let's see electric field at an axial point of dipole. AB is dipole, here minus q, this is plus q, and separation or distance of point P where electric field is to be found from the center of dipole is R. So let's find electric field due to charge minus q. So minus q, it will be q divided by 4 pi epsilon naught times distance squared. So R plus A whole square. This distance is A, this distance is A, and direction will be from P to A. From P to A. Now, we find electric field due to charge plus Q. It will be Q divided by 4 pi epsilon naught, and distance is from B to P, that is R minus A whole square. And its direction will be from B to P. From B to P. Now, net field E axial is equal to E minus Q plus E plus Q. We put the values. So from P to A, this is leftward. Let's write it as negative. So minus Q divided by 4 pi epsilon naught R plus A whole square, and E due to positive charge, let's write it as plus. So Q divided by 4 pi epsilon naught R minus A whole square. Now we take common Q divided by 4 pi epsilon naught, then minus 1 upon R plus A whole square plus 1 upon R minus A whole square. So that will give Q divided by 4 pi epsilon naught times, this will become minus R square, or first let's write properly. So minus R minus A whole square plus R plus A whole square divided by R square minus A square whole square. Now Q upon 4 pi epsilon naught times minus R square minus A square plus 2AR plus R square plus A square plus 2AR divided by R square minus A square whole square. Now here A square R square will cancel out, and we will get Q times 4AR divided by 4 pi epsilon naught. So we can write it as E axial equal to Q times 4AR divided by 4 pi epsilon naught R square minus A square whole square. Now we know that P equal to 2AQ. So we write it here. So we get 2pr divided by 4 pi epsilon naught r square minus a square whole square. Now we do some approximation. We assume that r square is greater than a square, so a square can be neglected. So we get 2pr divided by 4 pi epsilon naught r power 4, from where we get E axial equals 2p divided by 4 pi epsilon naught times r cube, and its direction, as we have seen, that it will be from positive charge toward point P. And here seen that this is minus q, this is plus q, and this is P. So net field will be from this point, suppose this is P, this is A, so it will be along dp, means towards the right. Now let's see electric field at an equatorial point of a dipole. So we consider a dipole, suppose minus q is here, plus q is here, and this is equatorial point, this point P, at which we have to find out electric field. So this angle is theta, this angle is also theta, this length is A, this length is A. We take this length as R. This is point P where electric field is to be found. Now, due to positive charge, the field will be like this. So, suppose this is E1, and due to negative charge, field will be like this. So this is E2. Now we draw a parallel line, axis of dipole, and let's find the components. Let's first evaluate whether modulus E1 and modulus E2 are equal. So modulus E1 will be q upon 4 pi epsilon naught, and this distance will be r square plus a square square root, that is whole power half. Similarly, this distance will also be, suppose we write it as a and it as b, so PA and PB will be equal. So here we write r square plus a square. Similarly, modulus E2, if we check, so it will be same, q divided by 4 pi epsilon naught r square plus a square. So let's take them as E. Now, electric field at this point due to E1 can be resolved into two parts. One component in this direction, and that will be E1 sin theta, and another component will be E1 cos theta. This angle is also theta. Similarly, due to E2, this angle will be theta. So again, we will get E2 cos theta, and in this direction there will be E2 sin theta. Since modulus of E1 and E2 are equal, so sin theta components will cancel out and net field will be due to cos theta components. So E equatorial can be given by E1 plus E2 times cos theta, that is 2E cos theta, as magnitude of E1 and E2 both are equal. Now we put the values twice of E. E is q divided by 4 pi epsilon naught times r square plus a square multiplied by cos theta, base upon hypotenuse. So base is a and hypotenuse is root of r square plus a square. So a divided by r square plus a square, that will give 2aq, which is p, divided by 4 pi epsilon naught r square plus a square whole power. Here this will be root, so whole power 3 by 2. Now again we use approximation where r square is greater than a square. In that case, we will get E equatorial equals P divided by 4 pi epsilon naught R square whole power 3 by 2. That is P divided by 4 pi epsilon naught R cube. If you recall, E axial was 2p divided by 4 pi epsilon naught R cube, and we have got E equatorial as P upon 4 pi epsilon naught R cube. Clearly, E axial is equal to twice of E equatorial, which is an important relation between the two. Now, let's go to next point. Decreasing electric field. Field lines are divergent. If field lines converge, in that case, we see that electric field is increasing. Clearly, EA will be greater than EB. Now, let's go to next point. Torque on dipole placed in uniform electric field. Here, AC is dipole. This is charge Q, this is charge minus Q. So there will be force in the direction of field QE, and there will be another force minus QE in this direction. If we find net force, so net force will be QE minus QE, which is equal to 0. Now consider torque. So torque equal to force into perpendicular distance. So force we write QE, and perpendicular distance will be AB, and in this triangle, this is right angle triangle, AB divided by AC equal to sine theta, and AC equal to 2A. So AB equals 2A sine theta. Now we write it here 2A sine theta, and we know that 2AQ equal to P, so it becomes PE sine theta. Now for maximum value of torque maximum, sine theta must be 1, that is theta equal to 90 degree. So tau maximum will be PE. In a vector form, if you want to write, so tau will be equal to P cross E. Now let's see next thing. Dipole in non-uniform field, torque and force. So if field is non-uniform, suppose we consider 2 points in field, this point A and this point B. We imagine that field is increasing, that is EA is less than EB. So here, if minus Q charge is there, so force on it will be minus EAQ, and at this point, if there is charge Q, that is, we are putting dipole along the direction of the field, so force on charge Q will be EBQ, because F equal to QE. So there will be net force towards right. Similarly, if field, if suppose at point A, field is larger, so in that case, EA will be greater than EB, and then minus EAQ will be greater than EBQ. Hence, net force will act towards left. Now, let's see area vector. So area is not a vector, but here we assume an area and draw perpendicular on it. Suppose this is n cap and this is area ds. So we write area vector ds equal to ds times n cap. So direction of n cap is perpendicular on the given surface. Electric flux, number of field lines coming out from any given surface that encloses a charge. So represented as phi e. Phi e is integration E dot ds. This is also equal to Q upon epsilon naught, that we will derive from using Gauss theorem. So let's see Gauss theorem. Gauss theorem is used to find the number of field lines or flux from any closed surface that includes a charge. Suppose we consider a sphere. Suppose it includes charge Q. We consider small area element ds here, and electric field lines would be directed outward. So this is the direction of E, and n cap will also be in the same direction. So theta between the two will be 0 degree. Now, as per Gauss theorem, phi E is equal to closed integral E dot ds, which is equal to closed integral E ds cos theta. Here theta is 0 degree, so we write cos 0 degree. So we get integration E ds, and we know that electric field due to charge, point charge at distance r, suppose the radius of the sphere is r, so at distance r is given by q upon 4 pi epsilon naught r square. So this will become q upon 4 pi epsilon naught r square times integration ds. And here integration ds means surface area of the sphere, that is 4 pi r square. So if we put this value here, so phi e will be equal to q divided by 4 pi epsilon naught r square times 4 pi r square. 4 pi r square will cancel out, and finally we will get phi e equal to q divided by epsilon naught. Now if we consider the unit of phi e, so it is derived from here. E dot ds means unit of electric field times unit of area, that is electric field is volt per meter times meter square, that will give volt into meter. So this is Gauss theorem. Now Gaussian surface, any hypothetical surface enclosing a charge within it. So it can be of any shape. Suppose enclosed charge Q1 here. Suppose there are two charges Q1, Q2 here. So Gaussian surface can be made like this. Now, Coulomb's law from Gauss theorem. So first of all, we will derive the expression of electric field, and then we will apply the formula F equal to Q. So consider again a sphere containing charge Q, and again we consider one small area element ds, and field lines will be directed like this. This is the direction of electric field. N cap will also be in the same direction. So theta equal to 0 degree. Now we write phi equal to integration close integral E dot ds or integration E ds cos 0 degree. This time we are not going to put the value of E, rather we will put the value of phi e. So phi e is from Gauss law, it is q upon epsilon naught. We have to find out E, and right here closed integral ds, and we know that closed integral ds represents surface area of the sphere, that is E times 4 pi r square. So q upon epsilon naught, from where we get E equals q upon 4 pi epsilon naught r square, which is expression of electric field. Now suppose there is any charge q0 here, so if it is placed in this electric field, it will experience a force. So that force will be given by q0 times electric field, that is q0 times q divided by 4 pi epsilon naught r square, which is Coulomb's law. Thank you for watching.